All right, let's get the show started. Hello, everyone. Thank you all for joining and welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm, and we have a lot of exciting talks lined up for you in the upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants shares their knowledge on the evolving technology trends in the industry that will help you keep learning and growing in your career. And this week, Naveen Rowthula, who is a passionate Java developer at InRhythm, is going to go over Java security. And I'm super excited for this talk. So without further ado, let's get it started, Naveen.
Cool. Good evening, everyone. As most of you already know, my name is Naveen Rowthula. I'm the senior software engineer at InRhythm. Today, I'm going to go over API security in Java. By end of this meeting, I'm hoping to give you a better understanding on concepts of securing APIs in Java. Uh, so, um, Okay, so this is the agenda. I plan to cover what is Java security, why and how we are why we secure an API, access control, authentication and authorization techniques. Also, I'm going to demonstrate how API security works in real world with a architectural design use case. Yeah, before getting started with the slides, I want to share something. When I started my research, found that over $43 billion stolen through e-business email compromise since 2016, as per our FBI reports. And most worryingly, there has been an increase of 65% regarded in uh, identified global losses between July 2019 and December 2021. That's a lot, isn't it? Yeah, so okay, let's get started with the fundamental topic. What is Java security? So yeah, basically Java security includes three layers. One is tools, APIs and libraries, and Java language and its runtime security. So although it has a great platform security by default, some of its other security features need to be understood and enabled by developers. Firstly, let's cover tools. Yeah, so tools are something JDK security package provides, and we use to set security policies on our local system and create applications that can work within the scope of our security policies set at remote sites for each of the individual developers, actually. So, for example, we use the key tool command and options to manage a key store of cryptographic keys, such as like X509 certificate chains and trusted certificates, which we see in our client laptops. So, and we have other tools such as jar signer, policy tool, to name a few, and we have more than that. So yeah, the next is going to be our APIs and libraries. So the APIs allows for multiple interoperable implementations, such as for algorithms and other security services. Yeah, services are implemented in providers, which are plugged into the JDK through a standard interface that makes it easy for applications to obtain security services without having to know anything about their implementation. That's cool, right? Um, so it also provides the classes and interfaces for the security framework. For example, if you see Java.security package includes classes that implement an easily configurable, fine-grained access control of security architecture. Um, yeah, so this package also supports the generation and storage of cryptographic public key pairs, as well as number of exportable cryptographic operations, including uh, those for message digest and signature generation, which we use for token signing. The last but not the least is the runtime security. So when we mean runtime security, it is a protection of workloads against active threats and malicious behavior once the workloads has been initialized and are running. Let's take in case of Kubernetes pods, when the pods has actually begun to run and interact interact with its host operating system, requesting for resources, communicating via the network. Uh, so which it can be defined as it currently running, right? And so any security solution that monitors and continuously protects the workloads at a runtime level is called like a runtime security solution. Yeah, so Java security package offers features like cryptography, authentication, and public key infrastructure as well. Plus, the Java code security is inherently stronger than some other coding languages. So, because of its strong data typing and other built-in security measures, so most of the fintech companies provide I mean, they use Java as their main application development language. So for example, if you see new Java 17 features include the ability to combat the ongoing problem of insecure deserialization. So now it depends on how well we utilize these features and packages to make it more secure. Yeah, so let's see. Yep. Okay. Oh, sorry. Yep. So let's talk about why we need to secure APIs. So in recent years, security has been a major focus. They expose sensitive medical, financial, and personal data for public consumption. So that said, not all data is same, nor should be protected in the same way. How you approach API security will depend on what kind of data is being transferred. So let's take an example. So if your API connects to a third-party application, understand how that app is funneling information back to the internet. To use the example, maybe you don't care if someone finds out what's in your fridge, but if they use the same API to track your location, you might be more concerned. So yeah, so since right? Okay. Since the number of APIs globally is growing rapidly, with that said, as per Postman reporting typical growth of 39% in the last year. So, and Gartner estimates that by 2022, 90% of web applications will have more attack surface exposed in APIs than in the UI side. And that API abuses will become the most frequent attack vector. So APIs, APIs are an attractive attack vector for adversaries since they are frequently publicly exposed with their documented endpoints, such as through Swagger, or whatnot. So excellent attack tools allow for ease of automation for those kind of attacks. So let's see, there are different types of security breaches in the current world. So I have listed few of them here. The first and foremost is man in the middle attack, which means so it involves a bad actor taking advantage of a trusted man in the middle to infiltrate your system. So most often, the hacker will start by compromising a customer system to launch an attack on your server. Yeah. So the second is phishing and spear phishing. So a phishing email is typically sent out to a larger number of recipients without a specific target in the hopes that casting a wide net will result in at least one recipient taking the bait. So spear phishing, on the other hand, has a specific target. So with the spear phishing, the hacker may have conducted research on the recipient. For example, they might uh, look through an individual social media profiles to determine key details like what company the victim works for, and then a hacker could use the information to pretend to be the recipient's employer, giving them like a better chance of successfully pursuing the victim to share valuable information, such as sometimes they even transfer funds to just to make people believe. Yeah. So the third is like password attack, hackers can often guess passwords by using social engineering to trick people or by brute force. So to reduce the risk of hackers guessing your passwords, make sure you have a unique password of each of your accounts. So and that each of these passwords are complex. So the most wide variety of attack is like malware. So a malware attack is an umbrella term that refers to a range of different types of security breaches. To name a few, this includes polymorphic viruses, which is nothing but changing their signatures frequently to evade signature-based antivirus, Trojan or Trojan horses, which are programs that appear as a typical file like an MP3 download, whatnot, but that hide malicious behavior. So, and the next one is file infectors, which are viruses that attach themselves to code on files. So we have ransomware, which are malware at viruses that block access to the victim's sensitive data until the victim pays a specific amount of money. Yeah, so fortunately for our developers, there are several well-established patterns and practices that rapidly reduce the risk of API vulnerabilities. So let's see them next. Yeah, so how to secure Java APIs. So yeah, so well, the first step towards securing an API is to have a deeper understanding of fundamental elements of API, such as TLS, rate limiting, and access control. So TLS, aka Transport Layer Security Protocol, is a cryptographic protocol to ensure all the communications are going over TCP or IP network. So an encrypted transport layer is essential for APIs to ensure that attackers are unable to eavesdrop data or tokens on the wire. So, and we can ensure that the client can validate the integrity of the server via a certificate checking, something like that. Next, we have rate limiting. This technology limits repeated and frequent users accessing from a particular IP address to a given API. For example, public APIs serve as the gateway to a business and as such must be protected from abuse via denial of service attacks. So, and adversely can trivially launch automated attacks against APIs, which can either degrade the performance of the application for legitimate users or or destroy the API due to resource exhaustion on the server. A secondary attack vector is to attempt to brute force either a sign up endpoint or a password reset endpoint by rapidly guessing the passwords or hashes with a dictionary attack. So this impacts the API by putting the load and uh, eventually turning into service unavailability. The next we have access control. Access control is a key foundation of API security and encompasses two elements. Firstly, authentication, which determines what they are authentication determines who is accessing an API, and authorization determines what they are allowed to do within the API. Okay, let's discuss more about access control. Yep. So authentication and authorization are two words used in the security world. Let's see how they are differentiated from each other. Firstly, authentication. So what is authentication then? Well, it's the process of identifying someone's identity by assuring that the person is the same as what he is claiming for. So it is used by both server and client. The server uses authentication when someone wants to access the information, and the server needs to know who is accessing the information. So the same way, the client uses it as when he wants to know that it's the same server that it claims to be. Um, the authentication by the server is done mostly by using the username or password, username and password. Other ways of authentication by the server can also be done using cards, retina scans, voice recognition, and fingerprints. So authentication does not ensure what tasks under a process one person can do. For example, what files he can view, read, or update. It mostly identifies who the person or system is actually. So then how does it different from authorization? Well, let's take a look at that. Authorization is the process of granting someone to do something. It means it's a way to check if the user has permission to use a resource or not. Um, yeah, it defines that what data and information one user can access. It is also said, it can also be pronounced as auth, aka authorization. So authorization usually works with authentication so that the system could know who is accessing the information. So authorization is not always necessary to access information available over the internet. So some data available over the internet can be accessed without any restrictions, such as you can read about any technology stuff that that is publicly available. In general, authentication is done by validating client's identity, either by storing their identity in LDAP or identity processing management processing. So whereas authorization is responsible to verify client scope of consuming specific resources by granting the access. Okay, since we have a better understanding of authentication and authorization, so let's dive in and know about how they are implemented. So let's take a look at authentication techniques first. So as per the security levels, the type of application, there are different types of authentication techniques. The first one and the basic one is password-based authentication. So it is the simplest way of authentication, which requires password for a particular username. If the password matches the username and both details match in the system's database, the user will be successfully authenticated. So the second one is passwordless authentication. So in this technique, the user doesn't need any password. Instead, he gets an OTP or link his registered mobile number or device or phone number. It can also be said as OTP-based authentication. The third one is two-factor authentication or multi-factor authentication, which is higher level of authentication. It requires additional PIN or security questions such as what is your favorite color, which town you belong to, so that it can authenticate the user more precisely. Next, we have single sign-on, which is often referred as SSO. Is a way to enable access to multiple applications with a single set of credentials. So it allows the user to sign in once, and it will automatically will be signed into all other web apps under the same centralized directory. Uh, yeah, the next is social authentication. So social authentication does not require any additional security. Instead, it verifies the user with the existing credentials for the available social network. Okay, so we have covered authentication techniques. So let's see what's under authorization techniques. Okay, so yeah, we have different types of authorization techniques. The first one is role-based access control. So which is often referred as RBAC. It's a technique given to users as per their role or profile in their organization. So we often refer them as AD groups, Active Directories or something. It can be implemented for system or user to system. And the second type of authorization is either using JSON Web Tokens, which we call JOTs. It's an open standard used to securely transmit the data between the parties in the form of JSON object. The users are verified and authorized using a private public key pair. Yeah, so next we have SAML. SAML stands for Security Assertion Markup Language. It is an open standard that provides authorization credentials to service providers. So these credentials are exchanged through digitally signed XML documents. So next we have OpenID authorization. So it helps the clients to verify the identity of users on the basis of authentication. So next we have OAuth. OAuth is an authorization protocol which enables the API to authenticate and access the requested resources. Now we understood the concepts of authentication and authorization, right? So now let's see how it fits in a real world use case. Uh, yeah. So here, before, sorry, let me take some water. Yep. So yeah, before getting started, this is one of the TLS flow where the user or client requests token by making a call via using a certificate that is provided by the uh, an organization, we can say. So we have API gateway to build secure real-end communication applications without having to provision or manage any servers to manage connections or large scale data exchanges. So first step is this. So first step is like this. We have authentication. So where we verify if client provided certificate is valid or not. So for this, we are connecting to LDAP for user data. For bad clients, we decline the request, providing that the client is not authenticated. So for a valid client, we'll proceed to do authorization. So in order to check if a user has permission to use resource, we can use policies for that. So I have attached a sample policy on the right side here, you can see. So policies contain end user service details such as identity of user, resource, API capabilities, which someone can access. We can authorize if this client has access to that particular resource or endpoint with right capabilities. So for invalid clients, we decline the request saying that the client is unauthorized. So whereas uh, for valid clients, we call a token generation library, which we can internally build one to generate either JOTs or SAML tokens based on the client's request. So, and before responding the token to the client, we usually cache the token for certain time, let's say 15 minutes, and then we respond back the token to the client. So which the client can use to consume specific resource from end service provider. So now when client uses this token, to call end service provider application, so they can actually verify if this token is valid, expired, or invalid. And with invalid tokens, they can with valid tokens they can perform the transaction, and for uh, invalid tokens, they'll get an exception saying that your token is expired. So yeah, so now we understood the concepts of how authentication and authorization and how we usually fits that model in our real world use case. So in a nutshell, APIs are an attractive attack vector for adversaries since they are frequently publicly exposed to documented outside. So we need to ensure API calls must be made with secure communication. And finally, Java provides the developer with a comprehensive security framework for writing applications, and also provides user or administrator with a set of tools to securely manage their applications. Yeah, so these are some of the references and useful links that you guys can go through later.